Hey everyone, and welcome. When you're writing code, you're basically just managing information, right? But have you ever stopped to think about how a computer actually knows the difference between a number you can add up and a word you just want to print on the screen? Well, today we're going to dive into the absolute bedrock of how Python keeps all that straight. Its data types. I mean, think about it. For us, the number 50 and the text 50 are conceptually similar. But for a computer, they are worlds apart. So how does it manage not to get them confused? This right here is the fundamental problem that data types were invented to solve. And the answer is with data types. The best way to think about a data type is like a label on a container. That label tells Python everything it needs to know. It says, hey, what's inside this box is a number. You can do math with it. Or, careful, this one's text. You can put it on the screen. It's Python's built-in organization system, and it is absolutely essential. Okay, so let's start with the absolute basics. These are the most fundamental containers, the ones you're going to be using all the time for just holding single pieces of information. First up, numbers. Python basically splits them into two main flavors. You've got your integers, or int for short. These are your nice, clean, whole numbers, 50, -10, a million. Think of counting things. Then you have floats. Floats are for when you need that decimal point precision, like for a price tag, 1999, or a measurement like 3.14. Now this right here, this is one of the most important distinctions to get right. The number 50 is an integer. Python knows it can do math with it. But the second you wrap it in quotation marks, it becomes a string, or str. It's just text now. It might look like a number, but to Python it's just characters. Try to add it to a real number, and the program will crash. The big takeaway? Those quotes change everything. And our final basic building block is the Boolean. It's the simplest one of all, but don't let that fool you. It is incredibly powerful. A Boolean can only have one of two values, true or false. That's it. Think of it as a light switch for your code's logic. Is the user logged in? True. Is the payment complete? False. All the decision-making your program does, it starts right here. Okay, so holding single items is great, but what happens when you need to store a whole bunch of things together? A list of users, a batch of coordinates, you name it. Well, let's level up and look at containers that are designed to hold other containers. Now, this table is your roadmap for the next few minutes. It's a fantastic cheat sheet that breaks down Python's 4 main collection types. We're going to look at them based on a few really important questions. Can you change them after you make them? Do they keep things in a specific order? And can you have duplicates? Let's unpack each one. First up, we have the list. You make one with square brackets. This is your flexible, all-purpose workhorse. You can add items, remove items, shuffle them around, whatever you need. It's perfect for something like a shopping list or a list of tasks where things are constantly changing. But you know what? That flexibility isn't always a good thing. What if you're storing something really important, something that should never change, like a set of fixed coordinates or system settings? You wouldn't want some other part of your program to accidentally delete an item, would you? A list can't protect you from that. And that's where the tuple comes in. A tuple is like a list's super secure sibling. It's ordered, just like a list, but, and this is the critical part, it's immutable. That's a fancy word for unchangeable. Once you create a tuple, it's sealed, locked in. Nothing can be added, removed, or changed. Those parentheses are more than just syntax. They're like a protective shell around your precious data. Next, we have the sets, and the set has one awesome superpower. It guarantees uniqueness. You could give it a massive list with tons of duplicate entries, say a log of every user ID that visited your site today, and the set will automatically filter it down to just the unique IDs. It doesn't care about order, which is what lets it be super fast at checking if an item already exists. And finally, the dictionary. This one is a total game changer. It's not just a sequence of items. It's a collection of key-value pairs. Think of it like a filing cabinet. You don't just throw papers in, you put them in labeled folders. Here, the label is the key, and the paper inside is the value. So you can look up information instantly using a unique key like name to get its value, Alice. It's absolutely perfect for storing structured data, like a user profile. So we have all these different types of containers, but just knowing they exist isn't enough. In the real world of coding, you need to be able to check what kind of data you're dealing with, and sometimes you even need to change it from one type to another. So how do you find out what you're working with? Well, Python gives you this awesome little detective tool called the type function. You can feed it any variable,
any piece of data, and it will tell you exactly what kind of container it is. This is a lifesaver when you're debugging and trying to figure out why your code isn't behaving the way you expect. And that leads us to this, one of the most famous error messages in all of Python. I promise you, every single developer has seen this type error 1,000 times. It's what happens when you try to smash two different data types together that don't mix, like trying to add a piece of text to a number. Python just throws its hands up and says, nope, I have no idea how to do that. But there's a fix, and it's called typecasting. It sounds complex, but it's actually super simple. It's just you, the programmer, taking charge and telling Python exactly what to do. You explicitly convert one type to another. In this case, we wrap the number 25 in the string function. That tells Python, hey, for a moment, I need you to treat this number as the text 25. And just like that, the error is gone.
And the process itself is wonderfully straightforward. You just take your variable and wrap it in the function for the data type you want it to become. If you have a string that looks like a number, like 100, you can wrap it in int function to turn it into a real number. If you need to turn a number into text, you just use string function. It's that easy. Python gives you a brand new value of the correct type, and you're good to go.
At this point, you might be thinking, okay, this is a lot of different rules and container types to remember. Why is this so important? Why can't Python just, figure it out on its own?
Well, it all comes down to this. Choosing the right data type, the right container for the job, is one of the most fundamental skills of a good programmer. First, it stops those annoying type error bugs before they even happen. Second, it actually helps Python run your code more efficiently because it doesn't have to guess what you're trying to do. And maybe most importantly, it makes your code so much easier to read. It makes your intentions crystal clear, not just for you 6 months from now, but for any other developer who has to look at your work. So when you get right down to it, data types aren't just a bunch of boring rules. They're the atoms of your program. They are the absolute basic fundamental building blocks you're given to create with. The real question is, now that you know what they are and how they work, what incredible complex worlds are you going to build with them?